Mary Schweitzer, she discovered that a fossilized T-Rex femur had preserved bone marrow. Yes, she is a Christian, but she holds to an evolutionary worldview. So at the end of the day, he needs to answer the question as to how could soft, stretchy tissues be preserved in dinosaur remains that evolutionists claim are no younger than 65 million years old. Even in the best state of bone preservation, the soft inner parts should have completely rotted away. And yes, there are rescue devices. There has been no conclusive. There's a lot of guesswork. There's a lot of, hypothesizing going on. But at the end of the day, if he admitted to this, to the obvious, that's going to call into question his entire evolutionary fairy tale and story. I want to hear how you explain, because I did ask you in my rebuttal, okay?
Yeah.
How could soft, stretchy tissue, and I'm going to give you ample time to answer the question, how could soft, stretchy tissues actually be preserved in dinosaur remains that evolutionists claim are no younger than 65 million years old? And I don't want you to give an answer like, oh, Mary Schweitzer was, a devoted Christian. We all know she's...
No, well, then put a period to your sentence so I can answer you.
Okay, go ahead.
Okay. The whole point is, as Schweitzer demonstrated in her technical paper about the processes, particularly involving iron, that can permit those sorts of things of which every single one of them is microscopically small in size. Almost all of the creationists that I've ever seen that have gone into this neglect to mention the scale of it. So that this is not something like Ötzi the Iceman, that's a well-preserved, massive body that's got all sorts of tissues intact. No, there are zero examples of that anywhere in the paleontological record. All of the stuff that Schweitzer has come up with, and for the same matter, Armitage's Triceratops horn,
I was going to ask you that one.
So, inside of sealed containers. And they have been treated with a variety of chemical areas, which is questionable whether or not the conclusions are what he wants to be. It's one of the reasons why he was let go from his position, because he was just leaping beyond what the actual data field was. Now, I know
what Mary Schweitzer's explanation for how, is she suggesting that iron was able to act as a preservative?
You not, in all of these years, the paper I think came out 5 years ago, in all of this time, your curiosity has been so lame that you've never thought to look it up. It's available. It's, I think, at PNAS.
Of course I know that in 2005 is when Mary Schweitzer actually discovered this fossilized T-Rex femur, but as of lately, after that, I think it was in 2012 and so on, she has been doing work in regards
have you kept up with not only her papers on dinosaurs, but also on turtles and other soft tissue in those? Have you read those?
Well, for one, I'll answer that question, but at the end of the day, you're not really
I just did answer the question that the material that is preserved is not giant masses of tissue. They are microscopic particles that are still found intact, buried inside of bones, in contexts in which it is not at all implausible that they could have survived for 100 million years, let alone...
Is that biofilm you're talking about? The microorganisms who...
No, read her bloody papers.
Well, from what I've seen, that those types of claims have not actually withstood...
That's the problem from what you've seen. And it seems as though, Standing, you don't look very far.
Is it not true that on Letters to a Creationist, who a lot of evolutionists look to attempt to refute Dr. John Sanford, didn't he say in one of his blogs or one of his writings there that there hasn't been an actual... Yes, there has been these suggestions here, there has been this explanation there, but nothing has actually been conclusive in explaining away these observations? Or are you saying that it is now conclusive that or is this just is it more than just storytelling, I guess?
I'll stand on the fact that none of her recent work, which is collaborative, it's not just her, has gotten any a pushback from the regular scientific community. When her findings were put out originally back in the 1990s, there was some quite legitimate skepticism that these might have been due to contamination.
1 minute
and
left.
the work, 1 minute left. The work eventually got more and more out, and that has obliterated. Now, you would think that if these supposedly blinded evolutionists with their millions of years really thought that this was a problem for their model, that they would be going after this tooth and tongue. But nobody is disputing.
Well, no, because they have that primary assumption that universal common ancestry is true. So everything has to be force fitted into that.
No,
paradigm.
it's not an assumption. It's an observation.
As creationists, well, obviously evolutionary scientists and you know, you're not going to be willing, due to that basic assumption and worldview, to actually consider or conclude what I think is a very reasonable possibility that dinosaurs have lived recently and coexisted with man. I've shown you paintings, mosaics, I've shown you historical accounts, I've shown you data here in regards to soft dinosaur tissue.
Yeah, even I know. You got
haven't scientists even discovered and detected intact DNA from so-called ancient dinosaur bones?
Brian Stevens says Mary Schweitzer found the
Schweitzer.
Thank you. Found the standing for truth tissue disagrees with soft tissue disagrees with standing for truth. Thanks for that super chat.
Remember, I've got in the link. If anybody follows up through that a bit, they'll be able to see the technical references from Proceedings in the National Academy of Sciences. You can find it that way, and therefore it's free, open access. Nobody has to take either one of our word for it. They can read the original.
Gotcha.
Well, and I just want to say that you can go look at on my channel some of the videos that Rob, Matt, and myself have made. You know, we talk about how, yes, Mary Schweitzer suggested that iron was able to act as a preservative over millions of years, and she says it's by cross-linking the soft tissue proteins to preserve its structural integrity. But it's only been shown that hemoglobin can be preserved for up to 2 years, and even this is highly concentrated iron solution that would not actually be expected to be found in the natural environment of the fossil. So like I said earlier, rescue device is storytelling. Mary Schweitzer, just like R.J. Downer, they have to hold the revolutionary
put that technical source up in the video description so everybody can track down on it, and we'll find out not the link to your video, but the technical source. You
can go look at the source itself, but it's not holding up to scrutiny.
In the early 90s, researchers from Montana State University made an amazing discovery. Inspecting a piece of T-Rex bone under a microscope, they could hardly believe their eyes. They could see dinosaur red blood cells. This discovery prompted lead scientist Mary Schweitzer to say, "It is exactly like looking at a slice of modern bone, but of course I couldn't believe it." I said to the lab technician, "The bones after all are 65 million years old. How could blood cells survive that long?" In the A Discover magazine article, Dr. Schweitzer explained further her response. "If you take blood cell samples and you stick them on the shelf, you have nothing recognizable in about a week. Why would there be anything left in dinosaurs? Well, the only reason there would be anything left in dinosaurs comes down to there being iron in the blood. However, this excuse falls short, as you are about to see. But first, let's touch on two other reasons that this cannot happen. As I am explaining these two other major problems with why dinosaur bones cannot be 65 million years old, look at all the findings of soft tissue discovered recently and how they know to look for it now, rather than just assume it doesn't exist at all. Problem number one, the mostly left-handed amino acids that should be equally right-handed and left-handed if they were Jurassic. They are not there. The laws of chemistry demonstrate that after death, amino acids go back to a 50-50 mixture of right and left-handed amino acids. The England's Royal Society published a time range for when this physical process to occur, which produces totally racemized amino acid in 100,000 to 1 million years maximum. So, obviously, that is not even close to 65 million years old. Another problem, the amino acid methionine is very susceptible to strong oxidizing agents like hydrosol, which would quickly oxidize methionine into methionine sulfoxide. The Nature Communications study results revealed unoxidized methionine in some of the Alberta dinosaur specimens. Also consider this. The research on the Egyptian mummies has established a 10,000-year upper limit for how long biological molecules can survive. Now, back to iron for just a moment. If you want to see the rescuing device for iron preservation fail in real time, it's easy. Just look for yourself. One of the most striking examples of soft tissue preservation in dinosaur fossils. If you look at the photos in the paper, you see no evidence of iron particles. The only place she saw iron was inside partially degraded tissue. You see, iron in blood, which gets released at death, cannot preserve all soft tissue decay for millions of years because it still degrades collagen proteins, which have also been found in some specimens. So while iron might preserve some soft tissue, it obviously is not responsible for all soft tissue preservation. Also consider that iron would be incapable of preserving soft dinosaur tissue if it could actually distribute it from the dinosaur's blood throughout all the tissue. Of course, Mary Schweitzer and her team totally submerged specimens to preserve them to obtain the results they desired. But the only way to accomplish this naturally is distributed by water. Well, guess what? That brings up another huge problem, as water also degrades soft tissue before iron can preserve it. In addition to this, soft tissue has also been found in bones not directly associated with iron-rich blood, like in the bone horn of the Triceratops and bird feathers. More problems with iron preservation with microbiologist Kevin Anderson later in this video. The old Earth idea was developed historically, not from letting the physical facts speak for themselves, but by imposing anti-biblical philosophical assumptions onto their geological observations, the idea driving the conclusion.
At the end of the day, yes, he does have rescue devices and stories for all of this, including the soft tissue in dinosaur bones. I mean, the discovery of soft tissues in dinosaur bones has actually become very much common and fairly common even among different dinosaur species. And he brought up the analysis of the Triceratops horn, and it contained original bone, soft tissue, and I think it even had, complete and very well preserved bone building cells, which are called osteocytes. So at the end of the day, he can try explaining all this away within our worldview, within the biblical based model. It all fits perfectly like a glove. The name of the debate, the title of the debate was, can man and dinosaur have coexisted? And I think I've provided more than enough evidence that they did, and evidence that they certainly could.
The big push at the moment is to explain it away, to come up with some explanation of how the tissue survived. There are several ideas out there. The most popular one at the moment is the one that Mary Schweitzer herself has proposed, where she proposed that in red blood cells you have hemoglobin, which of course is composed of iron, which is what then attracts and binds the oxygen, so that the hemoglobin in the red blood cell can transport the oxygen around in the body. Okay, what she's proposed is that upon the death of the animal, the red blood cells ruptured and they released the hemoglobin, which released the iron. In biological systems, iron can catalyze what's called a Hutton reaction. And this reaction, in essence, just causes proteins, for example, to cross-link. So it causes reactions of the proteins so that they actually become more resistant. So in this cross-link state, microbes don't degrade them as fast, enzymes don't degrade them as fast, they just simply don't compose as fast. And so she's proposed that that then explains how they could have lasted millions of years. We reject what she's at least proposed so far because we would say, first off, Hutton reactions are also going to leave signatures. They're going to leave signatures in how they're going to change the chemical state of certain amino acids. And in the protein analysis that's been done of like the collagen, for example, those amino acids in that protein don't have that altered chemical state that you would expect from a Hutton reaction. See, so we're not seeing the footprints that we would expect to see if these reactions were actually causing these massive changes to the proteins that were causing them to be preserved better. We would also say that the models themselves that have been studied take some of this into account. The collagen models, they take into account some of the physical changes that are going to occur to collagen that you would say may make it more resistant to degradation. And yet the studies show that it still doesn't last tens of millions of years. So there is no physical chemical evidence that's going to support the idea that proteins, any protein, is going to be able to last tens of millions of years. It's just strictly an extrapolation. It must last because we know these are old. And there becomes your conundrum. Again, the paradigm driving the conclusion. We also would challenge that the study that Dr. Schweitzer did, she used ostrich blood vessels. And she soaked them in water, soaked them in solutions of of iron from hemoglobin, soaked them in various solutions, and then monitored their degradation, how fast they degrade. And she reported that after 2 years, those that were exposed to the iron were, for the most part, undegraded. But first, 2 years at a steady temperature doesn't extrapolate to 65 million years at an unsteady temperature. Second, any technician can tell you that we take great pains in laboratories to preserve cells, to preserve protein, to preserve tissue. We freeze it. We deep freeze it. We freeze it, minus 200 degrees in liquid nitrogen. You don't leave it out. You don't expose it to water. You don't expose it to all the things that, in all honesty, these fossils tended to be exposed to, because everybody knows that accelerates degradation.
You wouldn't expect that.
It certainly would not be your first prediction. Even from a creationist position, we know full well that these fossils are exposed to ground level radiation. In fact, you could take almost any dinosaur fossil and put a Geiger counter against it and it'll light it up, because they've absorbed radiation. So even for 4,000 years, we say, wow, that's still quite a challenge to think they'd absorb radiation and still. So how are you going to explain 65 million years of exposure to this radiation? And Dr. Schweitzer's iron preservation model doesn't account for that.
So as a microbiologist, when you look at this, the two major paradigms that we have before us, and even though this is surprising, there is a paradigm between these two that better fits the evidence than the other.
I think we understand enough about the process and enough about tissue itself to recognize that the more clear, parsimonious, if you will, the simplest explanation is simply that the fossils aren't as old as they're being claimed to be. Dismiss the bacteria idea, you can dismiss the contamination idea. It is real dinosaur tissue, real dinosaur cells, and real dinosaur protein.
Okay, so once that is understood,
yes,
then what happens? Now this is shaking it up, I guess.
That becomes part of the controversy, because clearly you're now faced with how could you explain the survival of this, the pristine survival of this, not only for so long, but in very unpristine conditions. There's nothing pristine about Hell Creek, Montana, for example. It's not permafrost. It's not like these were in a deep freeze for millions of years. Like we mentioned before, the temperature fluctuations, water. Water will degrade proteins. When we pulled the horn out of the ground, it had water underneath it just from the seepage of rainwater. That's why when we first dug the horn out, we thought, there's nothing going to be in there. And there was. So these are not dry. They're not sealed in some kind of, stainless steel vault. They're subjected to all kinds of conditions that would degrade this stuff. And so then the controversy has been, how do you explain it? And if you read some of the literature, there's almost like desperation of, would you guys please explain this? Because they recognized what the implications of this could be. Now, some people would claim, well, it means nothing because we know how old they are, and therefore it just means it survived somehow, big deal. But how do you know how old they are? Well, you used methods, supposed methods of dating. Well, this is a method of dating. The tissue itself can't be discounted as part of a method of dating. So why do you say that doesn't count, but this does count? Well, it's all the paradigm drives your conclusions. The paradigm is it has to be old, therefore methods that give us an old fossil are what we choose. Something that doesn't give us an old fossil, like tissue, we have to reject or explain away.